Welcome to Science Era. In this video, we're going to discuss basic chemistry. Chemistry is the basis for how the body transforms and use energy and for how our cells use crucial molecules such as carbohydrates, lipids, proteins, and nucleic acid. Everything that happens in body from cells responding to their surrounding to breaking down the food we eat requires movement of chemicals. Chemistry helps us to understand the interaction of different molecules and why some interaction stores energy, such as in forms of fat, and why some energy is released, such as when enzyme breaks down our food. In this chapter, we present the basics of chemistry and biochemistry. Providing the background, you will need to understand the body function. So the main focus of this video is on the concepts of matter and energy. Two learning objectives are to differentiate matter from energy, and then we're going to list four major energy forms and provide one example of how each one is used in the body. So let's begin. Starting with the matter. Matter is anything that occupies spaces and has mass. Matter exists in solid, liquid, and gaseous state, all of which are found in the human body. Many people tend to confuse matter with weight. Matter is what we call the stuff of the universe, which can be seen, smelled, or felt, but weight is a measure of gravity pulling on the mass. So, as we said, matter exists in solid, liquid, and gaseous states in human body. Example of solid are bones and teeth in the body which have definite shape and volume. Next one is liquid. Liquid have definite volume but they conform to the shape of their container. Some examples of body liquid are blood plasma, blood, interstitial fluid that bathes all the body cells. Gases have neither a definite shape or nor a definite volume. The air we breathe is a mixture of gases. So we breathe in oxygen and we breathe out carbon dioxide. So this is an example of gas. Another property we need to remember of matter is physical and chemical changes. Matter may be changed both physically and chemically. Physical changes do not alter the basic nature of the substances, while chemical changes do alter the composition of substance. Some example of physical changes as seen on the screen are ice melting to water and food being cut into smaller pieces. Some example of chemical changes include fermenting of grapes to make wine, digestion of food in the body, combustion, rotting, all are the example of chemical changes. In contrast to matter, energy has no mass and do not take up space. It can only be measured by the impact it has on the matter. So there are two types of energy, potential energy and kinetic energy. Kinetic energy is what we call energy that is doing work or moving objects. The constant movement of tiniest bits of matters like atoms as well as large objects such as bouncing ball demonstrates the kinetic energy. Potential energy is what we term energy that is inert or stored as in the batteries of an unused toys. Both kinetic and potential work capabilities are present in all kinds of energy. So to summarize the difference between kinetic and potential energy, kinetic energy is doing work while potential energy is stored. So if we blow air in the balloon, and tie it together, the air is stored in the balloon. So this is an example of potential energy. But when balloon deflates and air comes out of it, this is an example of kinetic energy. Now let's look at different forms of energy. Energy have four forms: chemical energy, electrical energy, mechanical energy, and radiant energy. So, the first one is chemical energy. Chemical energy is stored in the bonds of chemical substances. When bonds are broken, the potential or stored energy is unleashed and become kinetic energy. So, as we said, kinetic energy is energy in action. For example, when gasoline molecules are broken apart in your automobile engine, the energy released power your cars. Similarly, the chemical energy harvested from food we eat fuels all the body activities. Next one is electrical energy. Electrical energy results from the movement of charged particles. For example, in your house, electrical energy is the flow of subatomic particles called electrons along the wiring. But in your body, an electrical current is generated when charged particles move across cell membrane. The nervous system uses electrical currents called nerve impulses to transmit messages from one part of body to another part of your body. The third form of energy is mechanical energy. Mechanical energy is directly involved in moving matters. When you pedal a bicycle, your legs provide mechanical energy that turns the wheels. We can take this example one step further. As the muscles in your legs shorten or contract, they pull on your bones, causing your limbs to move so that you can pull the pedal of the bike. The last one is radiant energy. Radiant energy, as the word says, travels in waves. That is, it is the energy of electromagnetic spectrum which include X-rays, infrared radiation, heat energy, visible light, radio and UV waves. Light energy which stimulates the retinas of your eyes is important in vision. UV wave cause sunburn, but they also stimulate our bodies to make vitamin D. Transformation of energy, or in other words, we can say energy form conversions. With a few exceptions, we can easily say that energy is easily converted from one form to another. For example, water stored in a dam possesses potential energy. When this water starts flowing through the gates of the dam it possesses, it turns into the kinetic energy. Water bearing kinetic energy rotates the impeller of the turbine. Turbine in turn rotates generator to produce the electrical energy. Electrical bulb converts this electrical energy to light and heat energy. So here you can see a cycle in which energy is transforming from potential energy to kinetic, then electrical, and then light and heat energy. Energy conversions are not always very efficient, and some of the initial energy supply is always lost to the environment as a heat or thermal energy. It is not really lost because we say that energy cannot be created or destroyed, but part given off as heat is unusable. From this example, we can easily demonstrate this principle by putting our finger close to a light bulb that has been lit for an hour or so. We will notice that some of the electrical energy reaching the bulb is producing heat instead of light. Likewise, all energy conversion in the body liberate heat. This heat makes us warm-blooded animals and contribute to our relatively high body temperature, which has an important influence on our body function. Let's see if we understand the concept. So, the question number one states matter and energy and how they are interrelated. Matter is a substance of a living and non-living object. Energy is mover of that substance, the ability to do work. Number two, what form of energy is used to transmit messages from one part of body to another? What form of energy fuels cellular processes? Electrical and chemical energies are both involved in transmitting messages in the body. What type of energy is available when we are still and when we are exercising? So, when we are still, we know that energy is stored in our body. We say that it is a potential energy. But when we are exercising, we call it a kinetic energy because we are moving. Number 4. What does it means when we say that some energy is lost every time energy changes from one form to another in the body? Every time energy changes from one form to another, some heat is given off to the environment and it is unusable. We say that this energy is lost in the environment. Thank you for watching. This brings us to the end of our concepts of matters and energy. In the next lesson, we're going to discuss composition of matter, where we're going to look at elements and atoms and their atomic structure, and we're going to also look at how do you identify the elements. If you like my video, don't forget to subscribe. Thank you.